Hey, what's going on, guys? In this video we are going to take a look at how to deal with Ohm's law and Kirchhoff's law together. If we have some equation, how we can solve this and stuff. So for example, let's say we have a KVL, that's Kirchhoff's voltage law, that says addition of all the voltage in the loop is equal to 0. Usually it comes with you know based on the direction, it plus or minus. So for example, I'm putting something like this. This is a 20 volt, and then let's say I1 current is there, and then 1k resistance. I1 current is passing through the 1k resistance, and then I3 current is passing through the 3k resistance, 3k ohm resistance, and that is equal to 0. And if we have another equation, that is another KVL, we have two loops. Like usually, if you remember, like if you have one loop like that, then there can be another loop. Okay, just for the illustration, here we can have some voltage sources. Okay, so this is some loop like that. So we can have another loop that is minus 10 voltage, and then minus I2 times 2k, minus I3 times 3k, that is equal to 0. So this is another KVL. This is just for the explanation, so we don't need this. Okay, now let's say we have a KCL. KCL says addition of all the current in a loop is equal to 0, entering or exiting. So if it's entering, we can put a plus, so I1 plus I2, and exiting we can put minus, so minus I3, that is equal to 0. So let's say we have these three equations there. How we can solve this and derive the value of I1, I2, and I3. So to do that, first what we can do is we can try to, here if you look at this one, the first equation. Okay, let's number these equations. This is equation number 1, equation number 2. Let's say this is equation number 3. Now if you look at the first equation, we have two unknown variable, I1 and I3. And if you look at the second equation, we have two unknown variable again, that is I2 and I3. So what is common in these two is I3. Okay, I3 is common, and I1 and I2 are different. So we first thing what we can do is we can try to eliminate one of the term, like we can add them together. Even if we add, like even if we subtract them, like if you subtract, this I3 will be cancelled. But even if you do that, then we have again two unknown variable. Okay, so to make this one easier, we had to do something like make this one unknown variable. To make this one unknown variable, instead of I1 plus I2, we can substitute I3. Like if you rearrange this third equation, we can say I1 plus I2 is equal to I3. Okay, so whenever we see I1 plus I2, instead of that, we can replace that one with I3. Okay, and if you look at these numbers, we can bring it to the other side. So for example, this 20 is a positive number, so I keep it in this side, and I bring all the other terms to the other side. So this is going to be 1k times I1, and here we have minus, so that's going to become plus in the other side. So this is going to be 3k times I3. Okay, let's call this one equation number 4. And if I can also rearrange this equation and make this one look better. So if I bring this minus 10 to the other side, that's going to be a plus 10, and others I keep it as it is. So this is going to be I also put the like terms together, like I2, we don't have I2, so I just put it right here, I2, and then we have I3, that is minus here. So I3 times 3k times I3. As you can see, we can directly add these two together and eliminate this 3k I3. If you add these two, the 3k I3 will eliminate. So this will become 30 is equal to so if you add plus minus is going to be minus. So 1k I1 minus 2k I2. Okay, we can call this equation as number 6. Okay. Call this equation as number 6. So this is one way to do this. Now what else we can do? If you compare equation number 6 okay, we have two unknown variables. There might, we can also could have done something like instead of this I3 I should have put I1 plus I2 as well. That's also applies. So if I do that, then I have to expand everything. So here here this is a minus, but we know the relations that I1 plus I2 is equal to I3. If I want to write this one in terms of what happens if I multiply everything by minus, so this will become minus, this become minus, this become plus. Okay, we can try that. But that doesn't work. So this is a very complicated one. Uh, we could try another different method. Okay, for equation 4 and 5, what I'm going to do is instead of this I3, I'm going to substitute I1 plus I2. So I'm going to get rid of this I3 here. I1 plus I2, I1 plus I2, and here what I can eliminate. I want to eliminate something that will make it easier to find something. So let's expand and add them together. Here you see we have I1, here we have I2. So if I expand this one, I can combine these things. So if I expand the fourth one, that is 20 is equal to 1k times I1 and then plus 3k times I1 plus 3k times I2, and then if I expand the fifth equation, that is 10 is equal to minus 2k times I2 minus 3k times I1 plus 3k times I2. Okay, so here as you can see, by adding these two, Let's combine the I1 I2 terms, so we will have only two unknown variable and combination. So I am bringing the 4 here, make it simpler. So 20 is equal to 1k I1 plus 3k I1, that is 4k I1, and plus 3k I2, and I bring the other one, that is 10, is equal to, we have minus 2k I2 and plus 3k I2, 3k plus minus 2k, that's 1k I2, 1k I2, and then minus 3k I1. So minus 3k I1 plus 1k I2. Here we can do something to eliminate one variable, so we can find the unknown variable. So here you can see this is 4 and minus 3. So if I want to make this one equal, I have to multiply this one by 3 and this one by 4. So if I do that, then the fourth equation become 20 times 3, that's 60, is equal to 4 times 3, that's 12k I1 plus 9k I2. And the fifth equation become, if you multiply everything by 4, that's become 40, that's equal to minus 12k I1 and then 4k I2. Okay, add these two together, then this will become 100 is equal to 9 plus 4, that is 13 k I2. Okay, so from this one I want to make sure if I did I make any mistake here. Okay, first let's look at this equation. 10 is equal to minus 3k I1 minus 3k I1 okay, I2 was initially minus 2k I2. Oh, I made a mistake here. This is minus 3k I2. So minus 2k I2 minus 3k I2, this is minus 5k I2 should be here. Minus 5k I2, and if I multiply this one by 3, that's 15 minus 15k I2. Okay, so these two eliminated, then minus 15 plus 4, that is minus 11 k I2 minus 11 k I2. Therefore we know that I2 is nothing but 100 divided by 11k. So 100 divided by 11k, and whatever the answer you get, and there's a minus also, so this is minus 100 divided by 11k. 11k. So this is the answer for I2. Now once you find I2, I1 is easy, because now what you have to do is in this equation right here, you have to just substitute I2 and then only one unknown variable. I1 is the only unknown variable. So you find the I1, and after you find out I1 and I2, then you add them together, that's the I3. Okay, so I will leave that over here. So only one unknown variable is a hard thing to find. Once you find that, everything else become easier. And that's it for this video. See you guys on my next video.